Hello, everyone. Welcome to our meetup event of Quantum Serbia. This is our 19th event since the group has started back in 2020. So Quantum Serbia is a group of enthusiasts in quantum computing and professionals, open for everybody, for all friends of goodwill all around the world. So we would like to promote quantum computing especially among the young generation of people in Serbia. Quantum technologies are nowadays very promising new field, and so we have started talking about this and learning ourselves, and also having this platform as the forum for exchanges and learning activities. So I'm very happy to be able to welcome today Tamás Varga, who is with us and who is going to tell us about Niels chess. This is a variant of quantum chess. So let me just say a couple of words about Tamás, and then I'm sure he will say even things that are more relevant for himself in this topic. So Tamás is from Switzerland. He's a postdoctoral researcher in quantum software engineering at the Constructor Institute Schaffhausen, and he's a founder of qedulab.com. So this is a company that is intended to make quantum computing more accessible to IT professionals. Tamás, I'm reading your biography, but I mean, I know that QEduLab, it exists already since several years. It was quite a success. So the program that you are offering to IT professionals on how to learn quantum computing is really very extensive and really great. So I invite everybody to visit this website. So Tamás, please, first of all, welcome. Thank you very much for accepting to do this presentation to us and to talk about Niels chess. How can we play quantum chess? Yes, let's rock and roll.
Okay, thank you very much, Sasha, for the introduction. I would also like to welcome everybody, and thanks for the invitation. I'm happy to be here, so let me share my presentation. So let me know if you can see the screen. Can you see my presentation?
Yes, I can see that. I hope.
Okay, yeah. Great. Okay, so just a moment. Okay, so my name is Tamás Varga, and today I will talk about Niels chess, which is a quantum variant of chess. And so here is the agenda for today. So I will talk a little bit about me, and then about Niels chess, and then I will introduce the essential rules of the game. I don't want to overwhelm you with all the details, so that's why you will only know those rules which are essential to play the game. And then I will show through an example how I imagine that people can play this game if they are beginners. And then we will solve some puzzles. It will be altogether 10 chess puzzles, including some historical games also. And then I will talk some words about potential variants, and that will conclude. So about me. So as Sasha already mentioned, I am a postdoctoral researcher at the Constructor Institute. My topic is quantum software engineering, and there I work on a high-level programming language in which you can put like numbers, strings, and booleans, and other data types into superposition, and you can manipulate them. So this is one thing. And then the second thing is that I am also interested in quantum technology education. I set up this website, qedulab.com, and this is where Niels chess was born, actually. And third, I am also selling SpinQ's quantum computers for the classroom. You can see some pictures here. I am the distributor in Switzerland. So that's about me. And now, so what is this Niels chess? So it's a chess with quantum rules. Basically, the game starts in the same initial position as normal chess, but then there are some additional rules that, and the same rules apply basically. But in addition, you can also create superposition, entanglement, and you can do tunneling and many other things you will see later. And this is a kind of a risk management. It has a risk management aspect because this game is about problem solving in an uncertain and interconnected environment, just like the world that we are living in today. And the specialty is that although this game is kind of related to high tech, but no computer is needed if you want to play it. Still, I am working on an online version, and you can see the screen plan on the right side. So I want to put it online so that it can reach more people over the internet. And I hope that this game will contribute to a quantum literacy for the people all around the world. And I already piloted this game with a small group of children, and I can say that I can confidently say that even children as young as 10 years old can understand how to make the moves, how to play this game. And you can see the paper here. This is a paper, and if you want to read more about the game. So now let's get to the rules. I will explain you the rules of the game. So the first rule is superposition. So have a look at this situation on the chessboard. And so here the white knight can, for example, attack the queen, but of course the queen can escape very easily if the white knight attacks like this. Or the white knight may attack the rook, but again the rook can escape very easily. However, in Niels chess, it can be that the knight attacks both the queen and the rook at the same time. And this is where the knight gets into a so-called superposition state. So here, can you see these two pieces? So imagine something like this. So if you can see such two pieces on the chessboard, one with a red mark and the other with a blue, then this means that this is one knight. Okay, this is not two knights. This is one knight. This is one knight which is here and here at the same time. This is called the superposition state, spatial superposition. So this is what you can see on the screen, that the knight is now in a spatial superposition, attacking both the queen and the rook at the same time. So the queen is more valuable. That's why let the queen escape. And now the knight can attack, can try to capture the rook. And now what happens is that we know that superposition states are extremely delicate. So, and which means that if the environment somehow disturbs them, like here, the rook disturbs the knight, because basically the knight bumps into the rook, kind of, and this will make the superposition state collapse. And in quantum mechanics, it says that the collapse is truly random. So we have to roll the dice. So here is the dice. It's a 5. And the rule is that if we roll an even number, then it will collapse on the square with the red mark on it. If we roll an odd number, then it will collapse on the square with the blue mark on it. So here 5 is an odd number, so it will collapse to h7. It will collapse onto the same square where the rook stands, and this means that the rook is captured. So white was lucky in this case. So now let's see another situation similar to the previous one. So here the knight goes into superposition and threatens the king and the queen at the same time. So now this is a check, because now the king is at risk of being captured. So the king has to get out of check. So the king moves, let's say, here. And then again, the knight can now attack the queen. And again, the knight will collapse. So we roll the dice. It's a 2. So 2 is an even number. So now the knight will collapse to the square with the red mark on it. So it will collapse here onto d4. So the queen has escaped, but still white did not lose the knight, because you can see that the knight is somehow protected by the queen here. So actually we attempted to capture the queen, and we were not lucky, and the knight collapsed here, but no problem, because the queen actually protects it. So this is you saw the check before, and now this is I will show you now a typical checkmate in this game. So here the rook goes into superposition, and now the king is in check. So now it is at risk of getting captured, and there is no way out of this check, and that's why it's a checkmate, because now wherever the king goes, it will always remain a check, and that's why this is a checkmate. And this is another situation. So now we give checkmate like this, and again the king is at risk of being captured, and there is no way out. However, now you may think that, okay, but what happens if the king tries to capture the queen? So what happens then is that, okay, actually this move is not allowed. And why it is not allowed? because now the queen will collapse. Now the queen is disturbed by the king, so it will now collapse. It will collapse randomly, and there is a 50% chance that it will collapse here on c3, on the square with the blue mark, and then that would mean that the king would be left in check. And in Niels chess, a move which can potentially leave the king in check is not allowed. It is similar to normal chess, that you are not allowed to make a move that would leave your king in check. Here, you are not allowed to make a move that would potentially leave your king in check. And that's why this move here is not allowed. So this is indeed a checkmate. So I don't know, is there any question so far? Just we are not too many people, so don't be shy. You can ask a question if you want, but I think it will be clearer in the puzzles.
How many?
So, yeah.
Yes, please. Somebody wanted to ask.
You can say.
Okay, I will ask. How many moves can we go in the future? I mean, how many moves can we chain while one figure is in superposition until that
Okay.
position still holds?
Yeah. So I want this game to be played by everybody, and that's why there is no chain. There is only one move. So, for example, now you cannot move with this queen, like for example here and here at the same time, and just continue this chain. It is not allowed. There is only one move, and you cannot go into into smaller and smaller superpositions, because then it would be super complicated. Yeah, and this was one of my problems with another variant of quantum chess, that it allows that, and yeah, I just don't like it, because it is very difficult to follow. Even this is difficult to follow. So if you allow more, it would be super difficult. But it's a nice question. Thank you. Okay, so let's.
Can the king be in superposition?
Sorry?
Can the king be in superposition?
Yes, anything can be in superposition, no exception. And the superposition can be in two ways. One way is that you move to two squares at the same time, and the other is that you stay and move at the same time. These are the two possibilities. Here, the queen was here, and it stayed and moved at the same time.
Oh, or it can move into left and right direction.
Wherever, yes.
Okay.
Wherever is allowed by normal chess rules, basically.
Oh.
Yeah. So here is the most complicated rule. This is entanglement. So here the bishop can join the superposition of this knight, which means that it can entangle with the knight, but it can only do that if it gets close to it. So close means that it will get into a position where it attacks the knight. So here it is possible because the bishop can move here in principle. So then basically the bishop will stay and move at the same time. And let's see what entanglement is. So here now the bishop is entangled with the knight. So it stayed and moved at the same time. And and you can see that the mark, the red and blue marks, are aligned along a diagonal. And then if they are aligned along the same diagonal, this means that they are entangled. So, and you can imagine, for example, you can see this here, and then if you want to entangle it, we just basically rotate it by 45 degrees on the chessboard. And then you can see that the marks of the knight and the bishop are aligned along the same diagonal, so they are entangled. This is how we know it. But then what does it mean that they are entangled? What does it mean practically? It means that, for example, now the knight attacks the pawn, and so what will happen now is that, of course, the knight is disturbed, so it will collapse randomly. But now this is entangled with the bishop, so this means that they will collapse together. They will collapse in a correlated fashion, in tandem. So let's see what happens. So now we have to roll the dice, and here we have to roll the dice once. So we roll the 4. So 4 is an even number, which means red. So both will collapse on the red square. See what happens? So now they will collapse. Now they have collapsed, and the pawn escaped. So this is entanglement. So once you entangle, when the time comes, they will collapse together. And then entanglement, yes?
Can you go back?
Yeah, just
how do you decide? I mean, if you want to entangle or if they get entangled?
So white decides. So for example, it could have been possible that the bishop simply goes into a superposition independent of the knight. It's fine. It doesn't have to entangle. So entanglement, whether to entangle or not, it is the decision of the player who is making the move.
So,
and also it is the decision of the player whether this mark here is blue or red, like, because it could be the other way around, right? So here I chose this way, but I could have chosen freely that this is red and this is blue. I am free to choose it.
So here in this case, we have a white player choosing to get entangled with a black knight.
Yes, and it's important that you can only do this by attacking an opponent player, okay? Because otherwise it would be too boring. Because if you could just go entangled with your own piece, then there would be no action, no excitement. And if you think about it, I said diagonal, and there are only two diagonals. So this means that we have this entanglement here, and now imagine that there is also some other entanglement with this diagonal. So this is this diagonal, and then there can be only one other diagonal. So there can be only two groups of pieces entangled. And then if you could entangle with your own piece, then it would be kind of at the very beginning of the game, you could just entangle, and then the opponent cannot entangle anymore. And that's why the rule is that you have to attack an opponent piece in superposition if you want to entangle. So there has to be some kind of action on the chessboard.
So now we can see that this red bishop is entangled with blue knight, or basically...
No. Wait. So the knight, this is one knight. Okay, so that's why I say black knight. This is one knight entangled with the white bishop.
Yeah, okay, yeah, sure.
Yeah, and then the entanglement is that you can talk about maybe connection, that the red, I call it indefinite piece. So the red the indefinite piece with the red mark is connected with this indefinite piece with the other red mark. So red is connected with red and blue with blue. And now if you roll the dice, it's 4, it means red. So when you collapse, it will collapse to red, both of them. And this is how, so either red, both of them red, or both of them blue. And that's why they are correlated, because there are no 4 combinations, but only 2.
Mm.
And that's why they are kind of connected this way. So now it will collapse to red. So, okay. Now, entanglement can result in weird situations. For example, here, the queen. So this is a check because the king is at risk of being captured. But now the king can get out of check in a rather weird way by entangling with the queen, because now the queen was already close, so it can entangle. And now this is not a check anymore, because a check means that there is a non-zero risk of the king getting captured. And here there is no risk at all, because if you try to capture the king like this is the only way to try to capture it. Then since these are entangled, this means that they will collapse either both on the red squares or both on the blue ones, and they will never collapse on the same square. So the king can never be captured. Whatever you roll the dice, they can never collapse on the same square. So there is no risk of being captured. So this situation was not a check. Okay. This is just something weird. Okay, so, and now let's go to the last rule I want to mention. This is tunneling. So here the rook wants to give a check to the king, and so it indicates that it wants to tunnel through the pawn. And then you have to roll the dice, because tunneling is an event which is highly unlikely in the quantum world even. And then if you roll a 6, then you will tunnel through the pawn, and then it's a check to the king. So you can tunnel right behind the pawn, and tunneling is only available for classical pieces at the moment, at least. Okay, and it has to be an opponent piece again, so that there is some action. So, but if you roll anything other than 6, like 1 to 5, then it means that the rook will actually bounce back and stay where it was. Okay, only you have to really be lucky. Only if you roll 6, you can tunnel through. So these are the rules. So,
but why?
Yep.
What is the quantum equivalent of this tunneling?
The tunneling is that there is a particle, and then there is some barrier, and the particle doesn't. So classically, the particle doesn't have enough energy to get through the barrier. However, with some very low probability, when it reaches the barrier, it kind of gets into superposition, and then later it will collapse. And with a very small probability, it will collapse on the other side of the barrier.
Mm. Okay.
And and the probability on the other side of the barrier decreases exponentially, and that's why it's a super low probability, but it exists. So like, and the analogy is that if you throw a tennis ball against the wall, if you do this for a long enough time, then once it will be on the other side. Of course, you have to wait more than the age of the universe, but still.
So this rook here, it can be only in e4, right? It cannot go to e3 or e2.
No, only e4. So only right behind. Only right behind, because this is like referring to quantum mechanics, that the probability exponentially decays. So it is super unlikely to tunnel here, but it's pretty much impossible to tunnel here because it decreases exponentially the chance that it can do that. Yeah, but right behind it can still, if you are lucky, you roll 6, then it will tunnel through. And sometimes you can give like a checkmate with this if you are lucky. Yeah.
But,
so
but
I don't
tunneling
know.
tunneling is not, I think, one of the principles of quantum computing, is it?
No, I don't. At least I'm not aware of it. So tunneling is really quantum physics. So for
Right.
for quantum computing, it's superposition and entanglement basically.
Right.
Yeah. And tunneling, I just put it here because it looks so cool. That it's
It
also
is.
yeah. It's also quantum mechanics, and yeah. Because if it was not there, I would miss it. That's the that's the thing. Okay. Although I don't think it has. I mean, you really have to be lucky to tunnel through, but still having the possibility, it makes the game nicer, I think. Okay, so if there are no more questions, then I can go to a quick example how to play. So how to play this game? So the short answer is I don't know, because I am also a beginner just like you. I am really waiting for my online version so that I can play against some kind of AI or machine learning, whatever, and then I will discover more patterns than I know today. So what I recommend for beginners, so here I will demonstrate it through a very famous game. It's Magnus Carlsen versus Sipke Ernst. It was played in 2004, and it goes by the name the Magnus effect. It was one of the most famous games of Magnus Carlsen. So what I would recommend is that you just start playing like normal chess and wait for the opportunity. And wait for the opportunity that you can do something interesting with a superposition move. So like this, so the match starts. It was actually a longer match, but here it will end within 5 moves. So Carlsen starts, and then next one, next one, next one, next. And now is the time. Now is the opportunity, because now, believe it or not, we can give a checkmate already.
Yeah.
If so, Carlsen did not notice because they were not playing quantum chess, but but in Niels chess, if you do this, now you make a superposition move, and this is a checkmate. This is a checkmate, so you can see that the king is threatened by both both indefinite pieces, the red and the blue, and there is no way out really. So, for example, if you try to capture this knight with this pawn, then you cannot do that. It is not allowed because then it will randomly collapse, and there's a 50% chance that it will collapse here, leaving your king in check. So so basically it is not allowed to attack, to try to capture this knight or this knight, because then it will collapse, and it might collapse on the other square, and then it will leave your king in check. And also the king cannot even entangle, because then if it tries to entangle, the problem is that then it will have to move here, but this knight here, this actually attacks both this position and also this position. So it will be a check anyway. So even if the king tries to entangle, it will be a check because this knight attacks both. So this is really a checkmate. So this is how we can end this game very fast, and then this game wouldn't have been so famous.
Tamás, for example, this pawn at E7, can
Yes.
it get into superposition with both superposition states of the knight?
No. So actually, in the first version of the game, it was like that, but now the rule is that you have to. So you can only get superposition if you move to unoccupied squares. If you move to unoccupied squares, because the problem would be that, so superposition is something which I want to see on the chessboard staying. Now, if you could do such a superposition that you move to a square which is already occupied, then it would collapse immediately. But it is not much fun. So I want it to stay for some moves at least. And that's why here this pawn cannot go into superposition by attacking the knight.
Because also in quantum computing, first you put your quantum system in superposition, and then you perform some operations.
Yeah. So as somebody told me that it's like I just want to keep the coherence. I just want to keep the state coherent. I don't want the state to collapse immediately, and that's why I don't allow it.
Okay.
But it's a good point. Okay, so if there are no more questions, I can go to the puzzles, and here you can test your knowledge. So let's go to the puzzles. So first, I will give you eight puzzles on a smaller chessboard, 5 times 6. I mean, this chess can be played on any chessboard, even 4x4. So let's go to the first one. Actually, this is very easy. So here the task is that white must give a checkmate in one move. So what is that move? If anybody knows, let me know. This is very easy. So nobody knows or nobody dares to say? You saw this before.
Yeah, to be honest, I never learned the classical chess, so
Oh, okay.
unfortunately, I can have. I know basics, so but I
Okay.
used to play as a kid.
Mm-hmm.
But I had no. Also, there was a bunch of kids playing chess, and nobody knew the rules. So I doubt my solution could be solution for this one.
Okay. Sasha, what do you think?
Oh, well, I think that the rook should go in the superposition in E3 and A6.
Yes, exactly. So this is the solution. That now the king is in check, like double trouble, and there is no way out. There is no way out. It cannot even entangle. It is too far away. It cannot get close. So there is no way out. So this is the solution. And then okay, now this is again. So it's black. So black gives a checkmate in one move. So this is a bit more difficult, but not too much more difficult. So what do you think? What is the solution here? So I have to tell you, just to ruin your confidence, that I did. So these are the puzzles that I showed to the 10 to 12-year-old children when I was making the pilot, and they could solve this.
Well, one of the ideas I have is, for example, the think you call it the figure that is in d4. You call it knight.
Yes. Yes,
Yeah,
knight.
we used to call it horse, so it took me a while to pick up. So basically, it could. So one of the ways it could go to position c2,
Mm-hmm.
and from there it could attack king.
Mm-hmm.
And well, the other one, I was thinking like if it went to position e2, it wouldn't be able to attack directly. But if king
But then-
tried to run away, yeah. But then if king tried to run away, then
Yeah, then the king could actually try to capture it. But here, the trick is that you can do superposition by staying and moving at the same time.
Oh, yes, staying and moving. Oh.
And that's so
Yeah.
you don't have to go to two places. You can stay and then go to here. But
yeah, actually, that's a good one.
and this is what people usually forget at the beginning. So this is the solution. That this is superposition. Now the king is under risk of being captured, and here there is no way out. The king might try to come here, but then it's a check here. So the king has no way out here. So and by the way, in Hungary we also call it horse, but I'm Hungarian originally, so we also call it horse. But in English it's called knight, I think. Yeah. Okay. So then the next puzzle. So here white gives a checkmate in one move. Needless to say, it must be a superposition move. But where?
Well, if it can move to E3 and A3 at the same time. Oh, C1 can move to E3 and E3 at the same time.
So E3 and C3 or A3? Which one do you?
I don't know.
So
if
if
what
it
is in C1? Is that the
it's a queen.
queen? Oh, the queen. So I suppose if the queen moved to C3 and C6, E3 at the same time.
Yeah, that's the solution. Yes. So
But wait a minute. But
Yeah.
black could do superposition and kill the one in C3 and then kill the one in E3 as well, right?
no. So with which would you do the superposition?
B3, which is a black queen,
Oh no.
can
So
kill.
no. So yes, the black queen can attack here, this one, and then, but this is not allowed because then the white queen would collapse, and there is a 50% chance that it would actually collapse here, leaving
Okay,
the
I
king,
see.
leaving the king in check. So the black queen is not allowed to attempt to capture the white queen because it might collapse here, leaving the king in check. So this is basically an important pattern that you are basically blocking. You are blocking the black queen to defend. So this gives the check, and this is blocking. Yeah.
I
And
guess
now there is
the sequence of how it happens. Do I move? Does the white queen move from C1 to C3 first, and then does a superposition, or does the move actually is duplicated in two directions?
I imagine it that you put the queen into superposition here on C1.
I see.
And they just move here and here, and just send them out.
But then you could do the same thing with the black queen in B3. You could put it in superposition and then attack the two white ones, right?
No. So first of all, the black. So when you go to superposition, you can only move to unoccupied squares. So even if you put this queen into superposition,
I see.
you cannot move here because this is already occupied. Yeah. So, but if you just take the black queen and try to capture here, you cannot do that because it's not allowed, because it might collapse here.
Got you.
But if you want to go to superposition, it has to be unoccupied squares, always unoccupied. Okay, so this is a checkmate. There is no way out for the king. Okay, let's go to number 4. Okay, this is a special one also. So now black gives checkmate in one move.
Well, can a6 moves diagonally? Oh no,
No,
it can't.
no,
Sorry, never mind. Never mind.
It can move straight only.
A2.
Yeah. So you mean that this moves to a2?
Yeah, I mean,
Sounds-
That's
actually,
50-50 though, right?
No, it's a risk. So the check means that it's a risk. It doesn't matter it's a 50% or 0.5%, it's a risk.
yeah, but if it moves to a2, then doesn't matter where the white king collapses. Is it the c2 or e2? It's still going to be a target.
Yeah, so basically this is the solution, and this is because now the king is at risk, right? Because then this rook may capture the king. There is a chance, right? And then now, if the king tries to get out of this risk, maybe this one maybe move out to here, but the problem is that this one will stay, and this will stay in check. So the risk will remain. The white cannot eliminate the risk with certainty. Okay, so white can move here and there, but it can only move with one of them, with one of these kings, and the other will stay in check. Okay, it's actually one king, but still, I think you understand what I am saying. So there is no way out for white. The risk, whatever white does, the risk of being captured will remain, and that's why it's a checkmate. So, for example, if this king comes here, it doesn't help, because then it will be still in risk, because white can attack this one, and then there is a 50% chance that the king will collapse here and will be captured. So this is not allowed to move here. Yeah. And similarly, if you move with this, it doesn't matter, because then you have the same risk as before. So this is,
Yeah, but for example, if let's just say the king from c2 moves to c3, so then so we just decide to move like that. But at which point do we roll the dice and see where it's going to collapse?
here we don't roll, so the king moves here. Now it is not collapsing, okay? But it remains in check, and this means that in a hypothetical next move, the rook can just come here, and then we roll the dice, and then there is a 50% chance that the king will collapse here, and then the rook will,
I get.
yeah, and the rook will capture it. So this check, even in normal chess, it is it's always the check means that in a hypothetical next move, the king could be captured, and that's why it's a check. And here in Niels' check, it's a bit relaxed, because I say that in a hypothetical next move, there is a non-zero chance that the king will be captured. So if you move here, it is not allowed, because in the next move in the next hypothetical move, there is a non-zero chance that the king will be captured, and that's why it's a check.
Yeah, this sounds more like quantum mechanics. It's more understandable than chess.
It sounds more like risk management to me. Yeah, so this game is more weird than quantum mechanics. Okay, so let's go to the next one. So this will be a bit tricky. Sorry for that in advance. So a bit similar situation, but with a bit more chess pieces. So now again, so how give you, so now black gives checkmate in one move. So this is the most difficult one, actually. So what is that one move?
D5 to B3.
D5 to D3.
Oh no, never mind.
Why?
No, no, that is difficult. Wait.
Okay, any other idea?
Hmm. Well, maybe black rook is going in superposition A2 and C6.
Okay,
Yes,
so
C6, yeah.
okay, so that is wrong. So, but I wanted to show you this exactly because this is what people usually say. So
Yeah.
and then so what happens here is that this is not a checkmate. So this is a check. Yes, it's a check because it has some chance to, for example, if this attacks this, then there will be a 1/4 of a chance to capture it. But this is not a checkmate because then the queen can go like this, and now it is defended. Okay, so it is no check anymore. So but the task was to checkmate in one move. So now, so what is this one move? So actually, Mike said it correctly, and he almost spoiled it. So because so the solution is this.
Hmm.
So it is because this is a threat now to the king, right? Because so this is a check because the king is under risk is at risk of being captured in a hypothetical next move, and now the king cannot get out of it. So white cannot do anything against it because, for example, you may think that okay, but what if the king tries to capture it like this? But this is not allowed because then the king will collapse, and there's a 50% chance that the king will collapse here, and so it will be left in check. So this move is not allowed because that it can potentially leave the king in check. Okay, so this means that this position is really a checkmate,
Hmm.
and a very weird one actually. Yeah. Okay. Yeah. So now to number 6. So now here the task is okay. So checkmate with a 50% chance. So black does something. So black makes a move, which results in a checkmate with a 50% chance. So what is that move?
No, I think the king here is at risk. It's at risk here from the knight with blue dot. But if this figure, I don't know how it's called in English, in e4, it can just take it and then reduce the risk.
Oh wait. So here, yeah. So here, black will give the checkmate. Black.
Black is giving the checkmate to the white king, right?
Yes. Yes.
I have your answer, I think. So if E4 moves to D3, it will collapse
Mhm.
the
knight,
superposition
yes.
with 50% chance that the
Yes.
B1 is empty, and then you have a checkmate.
Exactly. This is the solution. Congratulations. So this one is the solution because now it has 50% chance to actually collapse here and be captured. And then, let's assume that this happens. We are lucky. It collapses here, captured, and this is a checkmate. The king cannot go anywhere.
This is very cool, huh?
Yeah, it's a cool. So you
This
can.
is a new game.
Yeah. So you can set. So it requires a different way of thinking. It's really you have to take into consideration these chances, and then you whether you take the risk or you try to hedge that you have a superposition and you protect one of them just in case. So it's really, for example, if you have a situation which doesn't work out, you get unlucky, and then the question is whether you had a plan B for such events. Okay, but yeah, but here, so yeah, 50% chance it's a checkmate. Yeah. Okay, then let's go to 7. So this is entanglement. You see that they are aligned on the marks are aligned on the diagonal. So the rook and the bishop are entangled. So now black gives checkmate in one move. This is a bit difficult, maybe.
Sorry, could you repeat again? I was kind of distracted by something.
Okay, so here the rook and the bishop are entangled. You can see that the marks are aligned on the same diagonal. And here the black gives a checkmate in one move. So one move, checkmate. And black have the move.
So, for example, this A5 can capture C3.
Yeah, so that's the solution, yes?
Yes, yes.
This is the solution because there are two possibilities. So now they will collapse because they bumped into each other, so they will collapse. And now one possibility is the red, that the rook is captured, and the bishop will stay here, giving the check, and the king cannot do anything because this pawn is attacking this field. Yeah, so that's the checkmate. And the other possibility is that they will collapse on the blue square, and then this bishop will give the check, right? So let's see if I put something here. Just a moment. Okay, yeah, we roll the dice so that we can see. Okay, so we rolled a 3 because now they are collapsing. So 3 is an odd number, so it will collapse to blue, and then let's see what it does. So it will collapse to blue here, and this is a checkmate. Yeah. So it was really checkmate in one move. But if we had, for example, 4, then it would have collapsed to the red, and it would be similarly a checkmate. So yeah. Okay, so let's go to the last one. Okay, so here this is a check. So the black king is under risk of being captured. So how can the king escape? What can the king do?
Well, maybe queen can attack.
Sorry?
Yeah, maybe queen can attack diagonally.
But the
And
problem is that if the queen attacks, then there is a 50% chance that it will collapse here on the red square, and then leaving the king in check. So the queen attacking is not allowed because it can potentially leave the king in check because it may collapse here. So only the king can do something here.
So if you move the queen to C3.
Queen to C3. Oh, no. Because
Yeah.
if you do that, then the black king remains in check.
Oh,
yeah,
right.
Okay.
Well, I assume there's something with movement of king, and I don't really know what is that king can do. So
it can entangle.
yeah, but I don't know how.
Yeah.
Which movements. So when I was a kid, the way how we were playing is king could just move on one field next to where it's already.
Yes. It can move here, or here. Can you see my mouse, by the way?
Yes.
Yeah.
Okay, good. So it can move here, or here. It can move one square. Yeah. any square.
Well, maybe if it entangles the same way that so your rook is entangled.
Yeah, basically it has to entangle that the red rook attacks the blue king and the blue rook attacks the red king, and then yeah, but I know you have to get used to these rules. Of course, it will not happen in 1 hour. So so here it is. So it first, so it has to get close, otherwise it cannot entangle. So it has to move. Yeah, it can move also here, but let's say now we just want to move here. So now it will entangle, and then see what happens. So this is the entanglement, and you see that this is not a check anymore, because now the king is not at risk of being captured, because now if the rook tries to capture, let's say it tries this red, comes here to capture, then it will surely not collapse both on the same square, because one is red, the other is blue. So they will collapse either blue blue or red red. So this is not a check, because the rook has 0 chance to capture the king in a hypothetical next move. So this was the solution to the last puzzle. I don't know if there are no questions. We can go to the 2 historic games.
If I may ask one question.
Yeah.
Do you think what is more important here to know, quantum mechanics or chess?
I think chess, because I want this game to be played by let's say farmers, you know. So and they definitely don't know quantum mechanics. So basically, or I can put it this way: what is important here is to somehow get used to so-called quantum thinking. That in the quantum world, things can really be in superposition; they can be entangled, and this game will basically teaches you. This game teaches you those patterns of the quantum world, but you will not know like rigorous quantum mechanics. But the rules that I show here, so these so this game, in principle, this can be implemented with atoms and photons, and you know, so with, let's say, photons, you can implement this game physically. So the rules that you saw here, if you learn quantum mechanics or quantum information later, then you will recognize these patterns, because those happen exactly the same way in the quantum world.
Okay, so basically I have to learn chess, and then the fact that I know quantum mechanics will give me edge over Magnus Carlsen. I can win
Maybe
in the.
I don't think it will give you an edge if you learn quantum mechanics. So because you can learn these rules even without knowing that it is quantum mechanics. So if you just take somebody and just explain these rules without mentioning quantum mechanics, and then this person can just play by the rules, and then this person can beat a professor in quantum mechanics in this game.
Yeah. So basically, if I play against Magnus Carlsen,
then you will lose.
The possibility I'm going to win is definitely going to be 0. No way it can be non-zero.
No way. So even if you are a professor of quantum mechanics, you will lose against Magnus Carlsen in this game for sure.
Yeah, I hate this game.
No, but I mean, of course, it can be that Magnus Carlsen brain is too much organized towards normal chess, and that's why he will feel uncomfortable with this chess, and then you can beat him. It's possible.
Okay, I'll definitely try that.
That's called the quantum advantage.
Yeah, exactly. Yeah. So okay. So if we go to the real games, and like 2 historic games. So one is from 1956 with Bobby Fischer. So it is called the Game of the Century. Okay, and so this is in move 20. So Fischer is so black is black has the move. So this was around the middle of the game actually, but here we can finish the game earlier. So here is the situation. So Bobby Fischer is black, and then so now, okay, it might be a bit difficult. So it's a checkmate in 2 moves. So black has the move, and it will checkmate in 2 moves. So now I can help you a bit. That the first move is a classical move, and the second move is a superposition move. So now the first question is, okay, what do you think the first move is? Black has the move. Of course, it has to be a check. So I help you.
I assume the knight from E2
Mhm.
is going to move to G3, and then it will have king in chess. At the same time, bishop from C4 is going to have king in check while it's in position F.
Mhm.
But I have no idea what will happen if
Okay, but the first move
king
was
went to
already,
E.
yeah, this was right. This is the first move. And now the king has to get out of check, right? So the king has only one way to move, because we cannot capture the knight because the bishop is also attacking. So the king has to move. So now the king moves. And now the question is, what is the next step, the next move, which will make it a checkmate? So now
Well,
checkmate in 1 move.
okay, then knight can be at the same time in G3. So if king goes back to F, it will have in check, and at the same time it can be in E2, so it will have it in check while it's in G1.
Okay, so basically, just okay. So this was my solution until yesterday, but then I realized it was wrong, because if the knight moves here to E2, then actually what can happen is that the king can entangle with the knight, and then if the king entangles with the knight, then it can be that, for example, this is red, then the king will be here also red, and this is blue, and the king will be here blue. So the blue knight will attack the red king, and the red knight will attack the blue king. So if the knight moves to E2 in superposition, stays on G3 and moves to E2, then the king can entangle and temporarily avoid checkmate. So the solution is okay. Or anybody has another solution. But I cannot blame you, because I made the same mistake before. And I just noticed yesterday that I was wrong.
Wait a second. We have this black rook. Oh, no.
I can tell you the solution is weird.
Well, it's quantum mechanics, so that was expected.
Yes, but this is even more weird than so it's even more weird than the examples I showed you so far, actually.
So quantum chess level of weird.
Yes,
One move, only one move, right?
only one move. It's a checkmate. Yes. I think Bobby Fischer would know it, sure.
Well, then it should be the knight should go to F1 and E2.
Yeah, you are genius, you know. That's the solution. So this is the solution, the superposition. And why it is so weird? Okay, it's a check because the king is at risk of being captured. Yes, so it's a check. It's fine, and so nothing really can attack these knights here, other than the king. Only the king can attack. And now, if the king tries to capture this this knight here, then there is a 50% chance that it will actually succeed and it will capture this knight. But then it will be in check by the bishop. You see? Because so the king comes here and really captures the knight, because the knight will collapse here, and then it will open up open up the corridor for the bishop for the check. So this means that the king cannot do that. Is not allowed to do that because it would potentially expose it to check. So the king really has nothing to do. So this is that's why it's a very weird checkmate, because if the king does something, it will expose itself to it might expose itself to a check. So it cannot do anything. So this is the solution. Okay.
But now when I look at where your mouse is, I can really see let's say a very tiny knight is moving this position. So Sasha, did you see the solution there, or you thought on your own?
Okay, I see.
No, I didn't.
I'm pretty sure he has very good glasses.
But because here we don't have, if Tamás says one move, so we don't have really a lot of.
Yeah, maybe others were thinking for the rook to come here, and
Yeah,
something
but
like that.
that's not really. It cannot be.
Yeah, because the knight is here, this is here, so it's yeah.
So
Yeah, I was considering everything except for the knight.
Yes. Yeah, so this is really a weird checkmate, yes. But in quantum chess, it's possible. Okay, well, let's go to the next one. It's Kasparov versus Topalov, 1999. So this is also around the middle of the game. So Kasparov will have to move the white, and this is called Kasparov Immortal because it was also one of the most famous games from Kasparov. So don't get me wrong, I am not a chess expert. I'm a mediocre player. I just read this on the internet. Okay. So now white. So Kasparov is white. We are in the middle of the game, but we can finish it within one move. So one move, checkmate. So white has the move. One move, checkmate. What is that move?
Yeah, I assume it involves the black queen.
Yes. So white is moving. So I mean, it has to be the white queen, right? Because you have to give a check. You have to give a check to the black king.
Oh, okay, yeah, that makes sense.
Yeah. But how do you give that check? That's the question. It took me quite some time to realize it, to be honest.
B3 and C4.
You saw the picture. You saw the picture.
Yeah. Okay. Well, you're right. You should hide it.
Yeah. Yeah. Yes. So this is the solution, and this is again the pattern here is again blocking. So you have to block. You have to block the black queen from interfering. So then you do this, and now this is a check, obviously, because the king is at risk, and now the black queen cannot do anything, because if it tries to capture, or the pawn for that matter, because if they try to capture this queen here, then the queen will collapse, but there's a 50% chance that it will collapse here, leaving the king in check, and that's why it is not allowed that they try to capture. So this is really a checkmate. Black cannot do anything.
Or you mean it's not enough?
Yeah, yes. So it's so black is not allowed to try to capture, because that might leave the king in check, because it might collapse here onto b3. So if they try to, for example, attack, so try to capture, then they cannot do, this is not allowed, because there's a 50% chance that the queen, the white queen, would collapse here.
Mm.
And the king will be left in check. So this move is not allowed.
But for example, if it was a real game,
Yeah.
and I just wanted to take a risk, I was like,
Mhm.
okay, there's nothing for me left, and if I was black and I attacked the queen on c4, so there's still a 50% chance that I would protect the king.
Yes, 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 and this can be a variant of the game, because in other variants of a quantum chess, you are actually allowed. So the game ends when you actually capture the king.
Mm.
Okay, but I wanted to keep it more intellectual, because in the normal chess, it is not that you have to beat down the king and then you win, but you have to give a checkmate, like a situation from which there is no escape. And that's why here, so I don't want the game to end in a way that here, so the queen moves here, and then white is lucky, and then the game ends. So I just want to be a bit more intellectual. That's why I have my rules like that. So basically, what I say is that if you can set up this situation that that black cannot guarantee to eliminate the risk, then white deserves to win. So if you really compose such a situation, then you really deserve to win. Yeah.
Okay, so yeah, that's like real chess. It's when the king is in check and just can't move
Yeah.
anywhere.
Or you can think about also like this. So this situation, the king is under risk. So now this is embarrassing. It's very embarrassing for the king, right? That it's under risk, super embarrassing. And now, but if it cannot even do anything to guarantee to eliminate this risk of being captured, it is even more embarrassing. And it is so embarrassing that we call it checkmate. Because now the king is very embarrassed, because black really cannot do anything to fully 100% eliminate this risk. And this is so embarrassing that it's a checkmate.
Mm.
So that's the idea. Okay, so but now, since this game was not a quantum chess game, that's why what Kasparov did, he look at the rook. What Kasparov did is this. But now, if it's again a quantum chess game, then now black, Topalov, has the chance to give a checkmate in 2 moves. And I think there are multiple solutions here, but the simplest is when the first move is a classical move, no superposition. So the first move is a normal move, and the second move will be a superposition. So what do you think will be the first move from black?
So black is giving the checkmate to the white
Yeah.
king.
In 2 moves. And the simplest is when the first move is a classical move, is a normal move.
So I might be breaking rules of classical chess, but maybe queen can go to d1,
Yes.
and then go into position for stay there and go to b2 at the same time.
Okay, wait. So let's take, so basically this is the first move. This is the first move, and now it's a check. So now the king has to escape, right? Now the king has to go somewhere. So actually, let's say the king goes here, but actually it doesn't matter if it goes here or here. It doesn't matter if it goes to b2 or a2. The solution will be the same. And now what is the next move for black to give the checkmate?
Well, maybe just move towards a1 and b1 at the same time, or something like that.
Exactly. This is the solution. A1, B1. Because here, so now this is, so the king is at risk, and the king cannot even entangle with the queen. I mean, it could, it is not allowed to entangle, because because the problem is that this king here is it attacked by both of these indefinite pieces, the blue and the red. Both of them are attacking this position. And if you want to entangle, then it's staying and moving. So let's say if you want to entangle, then one indefinite king piece has to stay here. But that indefinite piece, let's say it will be blue, then it will be attacked by the blue queen. If it is red, then it will be attacked by the red queen. So it's always a risk to be captured. So the king cannot entangle here. Okay.
But is there a possibility for king to be at the same time, like entangle, at the same time in A2 and B2, but red one to be okay? Yeah, queen can attack diagonally, so it still wouldn't matter. So
Yeah,
still, it doesn't matter what king does.
Yeah, because it has to stay here, stay and move, and this one something will stay here, and you can tell me the color. You can tell me any color, blue or red, doesn't matter, because if you say blue, then this will attack it, and then it will have a 50% chance to capture if it goes here. If it is red, then this will have a 50% chance to capture the king. So it cannot even entangle in a way that eliminates the risk. Crystal clear?
Yeah.
Okay, so then, yeah, so this was the last puzzle. I hope you enjoyed the puzzles. And
Yeah, very interesting.
yeah, and then, yeah, as I said here, the good thing is that you can make, if you have 3 chess sets, you can make these at home, and you can already play. And you have the paper, you can read the rules, and if you don't like a rule, feel free to change it, because you are, I mean, you are free to change it because it's a physical board. There is no computer program defining the rules, and you can have your own rules as you wish. Or if you are a quantum educator, then you can figure out other rules to demonstrate different quantum effects on the chessboard, for example. Okay, and here we go to variants. So really, the first thing I want to say, the limit is the imagination. So consider, for example, this one here. What is new here is that the red and the blue, they are facing the opposite direction, you see? Before it was always the same direction. Now the red is facing the opponent or downwards. The blue is facing the player upwards, okay? So opposite direction. So what can this mean? So this can mean, for example, an unequal superposition, which is that when this knight collapses, then it will collapse in a way that 1 to 4 means red, and only 5 and 6 means blue. So blue has less chance to be collapsed here. And if you have this rule, then you can play with this thing that for example, when you attack something that is important for you, then you will attack it with the red one, which has more chance to be collapsed, right? And then if you attack something which is not that important, then it will have less chance to collapse there. So this is also a nice rule. Okay, but what else it can mean? So the same thing, you can have a variant where this means basically a phase. It can mean a relative phase. So when the mark is here, this can be like a plus state, if you know some quantum mechanics. So this is the equal superposition, the plus state, but when you opt for the mark to be here, when you create the superposition, then this can be the minus. It can be the minus state, right? So this is equal superposition, but with a 180-degree phase. And then, since you can really rotate these guys as you wish, you can also have rules on your own that you can basically also introduce complex amplitudes if you want to. I don't recommend it, but you can. It can be super complicated if you do, and then you can basically have things analogous to the X gate. For example, here, let's assume now this is an unequal superposition. There is more chance to to collapse here to the red. And then you can have, how can you have the X gate? Is that you basically rotate both of them by 180 degrees, and then you can just have the extra rule that it's always the mark which is facing the opponent, which is facing downwards, has the more chance, and the mark which is facing upwards has the less chance to be collapsed into. And then now if you rotate both of them by 180 degrees, then they will really flip. Then suddenly red will be the one with the less chance because the red will face upwards, and blue will be the more chance because it will face downwards. So you can, and then, but if you imagine these as a relative phase, then you can implement like a Z gate or a Hadamard gate. So you can introduce such rules. You can have partial collapse. Imagine that you not only have red and blue, but you have like green also. Okay, and the knight can go to three positions. Okay, like 3 squares, three, and then when you bump into one of them, then it can be then it will be something which is called a partial collapse in quantum mechanics. So you can illustrate also that, but this is more for educators if they want to illustrate a quantum effects for example, for smaller children. And then it can also be that there is no randomness at all, because you can have a variant, for example, that that this means a minus state here, and then when something bumps into it, then it will not induce a random collapse, but it will kind of induce like a Hadamard gate, which is deterministic. So you can have as many variants as you want. So, and your idea comes here, and so in the paper, so I have a paper, the first paper about this game, and I have like at least like 10 variants in that paper. There is one official variant, which is more or less what I told you, and there are many other variants. But of course, it is maybe not too good if you have too many variants. But I just want to indicate that educators can use this game to illustrate quantum effects in the classroom. Okay, so and with this, I would like to thank you. But since we have a bit more time, I can show you just one more thing, because I say risk management. So if you look at this situation here, so now, so black, it seems that black has some advantage here because it has a rook, while white has only a knight, and the rook is stronger than the knight. So now white might think that, okay, so now black has more than 50% chance to win. But then if I come here, attack, so I try to capture this queen, then I will have a 50% chance that I will succeed, and it will be a checkmate immediately. So I can win with a 50% chance. However, if I don't do this, then I will have less than 50% chance to win. And now, so white can think like this, and then white will perceive that, oh, this might be a good risk to take, because before I had like 40% chance to win, but if I attack this queen here, then I will have suddenly 50% chance to win. So of course, yeah, but it can also be that white is more risk averse, and for example, and white can actually argue that maybe actually my position is better because this queen is already in superposition, and we can argue that if the queen is already in superposition, then it's actually weaker than a queen which is not yet in superposition. But anyway, and then, but if white is just simply risk averse, then white can choose this, and then they can play further. So this is what I meant by risk management, that in Niels chess you will have to face such situations, whether you risk or you don't risk, or whether you really want to win a kind of without risk, that you set up your situation that everything is protected. Yeah, and but
Stochastic.
yeah, you can make it fully stochastic, and then your opponent will get mad because it will be so complicated. But you can also be more careful and just avoid such risky situations by doing this step with the knight, and then you avoid.
So that might be the only way to beat Magnus Carlsen.
Yes, exactly. So actually, I don't know because I don't have enough experience with this game. But if it is possible always to basically force a situation where you can be lucky, then you can beat Magnus Carlsen. However, if there are techniques that actually you can play in a way that everything is just protected enough, and then luck will not play a too big role in the game. But I don't know which is true. Whether it's a fully crazy game or whether you can play it in a way that it's much less risky.
So,
Well, either way, this makes my chances non-zero, and it's
Exactly.
all I need.
Yes, exactly.
if we do 1,000 shots, like or
Yes, yes.
game, then it is approaching zero.
Yeah. I mean, I don't know if people want to implement this on a quantum computer, because I deliberately designed this game that it can be played physically, like on a traditional board, that we don't need a quantum computer, and you can see all the situation on the chessboard. Nothing is hidden, and it's easy to interpret. Yeah. But it can be also an interesting question. Maybe there will be a quantum algorithm which will be more efficient. So okay, an AI question can be that if we implement a player using a classical computer and we implement a player using a quantum computer, will they be equal, or will the quantum one be better? I don't know. I don't know the answer. Okay, but nevertheless, thank you very much for your attention. So this was what I wanted to show you today. Yeah, just feel free to ask me questions, and just I think Sasha you can send the presentation, the PDF, and then they can also find the paper, and they can go to my website. Yeah, and yeah, just have fun and happy playing.
Thank you very much, Tamás. This is excellent, really wonderful game, and very stimulating.
Thank you.
Okay, so we are just few. Slobodan, Mike, if you would like to ask some questions or comments, feel free.
Yeah, I just want to thank you. It's very, very interesting, and as Sasha mentioned, it's really, really engaging. So I think this is the best form of presenting something. Just have small tests and quizzes, and just everybody will just want to take part of it.
Yeah, and you don't fall asleep.
Yeah.
Thank you very much.
Tamás, what are the next steps? So you created this game. So this is your invention. I mean, this.
Yeah. So actually, the next step is to write the web application, like just the JavaScript stuff with some tree, evaluating some tree, and then doing kind of AI. And yeah, and also what I did is that there is a patent pending about this. I mean, you cannot patent a game, but you can patent the game hardware. And then yeah, so but don't worry, you can play it at home. So okay, so it is all allowed. Okay, yeah. So and then later it would be nice if we could produce this game like physically. That would be very nice.
And sell it to schools or chess clubs, or
Yeah, or
a club,
just
Niels chess club.
just to anybody basically. I mean, just like you would buy a normal chessboard for home. Yeah, that's the idea. And but first of all, I would like this game that I can reach many people with it. That's the idea, and that's why I am doing the web application, kind of, to put it online.
Okay, wonderful. So I will end here. This video will be provided in Quantum Serbia YouTube channel. Thank you all who were present in this meetup event, and also to those who are going to watch this video. Take a look at our Quantum Serbia meetup events. Join our LinkedIn group, or follow our YouTube Quantum Serbia videos. Thank you, Tamás. Thank you all. Have a nice evening.
Thank you too. Bye bye.